Alright, last one of these. For this one, I have two cars that are traveling towards each other on the same road. The car traveling east is going 10 miles per hour faster than the car traveling west. So that's going to be my two situations. We're going to have east and west. The cars begin 200 miles apart and they pass when the car traveling east has gone 110 miles. How fast is each car going? Alright, so this one does have a good bit going on. So let's see if we can kind of think about what's happening for a little bit. So let's say we have this road and we have one car that is going this way and the other car is going this way. The total distance, it says the cars begin 200 miles apart. So when they start, they are a total of 200 miles apart. We know that when they pass each other, the car traveling east has gone 110 miles. So miles is a distance, right? And that's for the east car. So we can put the 110 in here for the east car. Now for the west, we kind of have to use the information that was given. So when the cars pass each other, that means that they have at the same place. I'm sorry, wasn't quite sure how to word that. So if the east car has gone 110 miles, then the west car must have traveled the 200 miles that they were total apart minus that 110. And that gives me 90 miles. So the distance of the west car is 90. So when they pass, one of the cars has gone 110 miles and one has gone 90 to make the total 200. Okay? We also know that the car traveling east is going 10 miles per hour, that's a rate or a speed, than the car traveling west. So that means we don't know how fast the west car is moving, but whatever that rate is, the east car is going 10 miles per hour faster. And now I bet you can see a pattern from the other two. We have information for distance and rate that we can use to write expressions for time. So for the east car, the time will be its distance over its rate. And for the west car, its time will be its distance over its rate. And we can set those two equal to each other because when they pass, that means they've been traveling the same amount of time, right? So we can set up our equation. 110 over x plus 10 equals 90 over x. And then right back through our normal process, right? My LCD is going to be x times x plus 10. We're going to need to multiply both sides of the equation by that LCD. And then look for factors we can reduce. So on the left side, the x plus 10s match, so we can cancel those. So I'm left with x times 110. And on the right hand side, my x's match, so we can cancel those off. And I'm left with 90 times x plus 10. Alright, so now we just need to solve this. So I'm going to distribute 90 times x is 90x plus 90 times 10 is 900. This is a linear equation again. The highest variable exponent is 1. So I need to move my x terms together. So I'm going to subtract the 90x. 110x minus 90x leaves me with 20x equals 900. Divide both sides by 20. And I get x equal to 45. Alright, so for what it means, this problem is asking how fast each car is going. So you can call rate or speed. Let's say the speed of the east car and the speed of the west car. So if you go back to your table, x is right here. That is the rate of the west car. So we know the speed of the west car is 45, and the speed in this problem is miles per hour. And then that means that the speed of the east car must be 45 plus 10, which gives me 55 miles per hour.